Mathematics 1, Specimen Examination, Question B6. This is the second version. Solve the following simultaneous equations using Cramer's method. The first thing we have to do is to write the equations in matrix form. So we look at the coefficients 2, 4, 6, and we put those into an array, 2, 4, 6. There's the x, y and z vector, and those are the constants on the right hand side. The next task is to calculate the determinant of this array. We'll write the matrix and then we repeat the first column and the second column. I'm going to call the first set of diagonals the reds because I'm using a red pen. So I'm going to get 2 times minus 3 times 5. 2 times 5 is 10. 10 times minus 3 gives us minus 30. I've got 4 times 4 is 16 times 2 is 32. And I've got 6 times 3 is 18 times 5 is 90, which is what I've got there. So now I add these numbers together. I've got minus 30 plus 32, which gives me 2. 90 plus 2 gives me 92. Now we look at diagonals going in the opposite direction. I'm going to call these the blues. So what we have is 6 times minus 3 times 2. Well, 2 times 3 is 6, and minus 6 times 6 gives us minus 36. Then I've got 2 times 4 times 5. Well, 2 times 5 is 10, times 4 gives us 40. And then we've got 4 times 3 times 5. Well, 4 5s are 20, times 3 is 60. We add these numbers together. So 40 minus 36 will give us 4, and 4 plus 60 is 64. To find the determinant of the array here, we're going to subtract 64 from 92, which is going to give us 28. The next task is to find the x determinant, and how we do that is we replace the x column with the constants from the right hand side. And now, as before, we're going to calculate the reds. So 22 times minus 3 times 5 plus 4 times 4 times 19 plus 6 times 4 times 5. That gives us 94. And then for the blues, we've got 6 times minus 3 times 19, 22 times 4 times 5, plus 4 times 4 times 5, which gives us 178. We now subtract 178 from 94, giving us minus 84. Now we need to find the y determinant. So just as before, what we do is replace the y column with the constants from the right hand side. And to get the reds, we're going to have 2 times 4 times 5 plus 22 times 4 times 2 plus 6 times 3 times 19, and that gives us 558. And then for the blues, we're going to have 6 times 4 times 2 plus 2 times 4 times 19 plus 22 times 3 times 5, and that gives us 530. 558 minus 530 gives us 28. And then finally, we need to calculate the z's. We replace the z column with the constants from the right hand side. For the reds, we've got 2 times minus 3 times 19 plus 4 times 4 times 2 plus 22 times 3 times 5, and that should give us 248. And for the blues, we're going to have 22 times minus 3 times 2 plus 2 times 4 times 5 plus 4 times 3 times 19, which should give us 136. So we now subtract 136 from 248 and we get 112. Now to find x, we're going to divide dx by d. To find y, we're going to divide dy by d, and to find z, we're going to divide dz by d. So x is equal to dx divided by d, which is minus 84 over 28, which gives us minus 3. Y is equal to 28 over 28, which is 1. And z is equal to 112 divided by 28, which is equal to 4. And that's the answer to part A. Part B says, show that your answers are correct. Well, the way to do that is to put our answers into any one of these equations and make sure that the values add up to whatever it is on the right hand side. So I'm going to take the first equation. We've got 2x plus 4y plus 6z. So that's 2 times minus 3, 4 times 1 and 6 times 4. 2 times minus 3 is minus 6, 4 times 1 is 4, and 6 times 4 is 24. Minus 6 plus 4 gives us minus 2, so that is going to give us the answer 22. And that means our answer is correct.